Okay, so now what we're going to do is we're going to do the same problem in a second way. Now, this is an opinion. You can take it or leave it. I find this way a bit more difficult than the first way. But again, you can form your own opinion. But I truly do think this is a little bit more complicated. So what we're going to do is we're going to kind of sketch a representation of our vectors. Okay, again, this is just kind of a sketch. So I'm going to draw V first. Okay, there's my angle V. It has a length of 400 and a theta of 25 degrees. Okay, and then I'm going to draw in my vector U. Which has a length of 300 and a theta of 70 degrees. Okay, now remember your theta is measured from standard position, the positive x-axis. Okay, so what we're going to do is we're going to use our parallelogram rule, okay, and we're going to use our two vectors to draw a parallelogram. Let's see here. Okay. So I'm going to replicate this red vector. 1, 2, 3, 4, 5, 6. It doesn't have to be perfect. But I find the more accurate you are, the more it helps. But that's just me. Okay, there is my U and then my V. Oops. Let's try that again. Okay, so if this has an angle of 25 and this right here has an angle of 70, then the angle in between is going to be 45. Now, since this is a parallelogram, opposite angles are equal, so this is 45. And then if I subtract from 360 and divide by 2, because it's a parallelogram, I get 135 and 135. This again has a length of 300. This has a length of 400. Okay, so if I add my two vectors and find the magnitude and the angle of the vector, I am going to use, believe it or not, law of cosines and law of sines. So to find the magnitude use law of cosines. And then to find the direction angle, we are going to use law of sines. Okay, so we want to find another color. Right. Okay, so that is U plus V. All right, so I know what I want to find. I know how I'm going to find it. So let's add some more labels. Okay, so you will notice, oops, that my parallelogram is actually two triangles. Okay, So if I look really carefully, I can see my triangle here, and here, and there. Okay, so find the length of u plus v. I'm going to use law of cosines. So now if you remember, law of cosines looks like this. Okay, and we use it when we have side angle side or two sides and an included angle. So our A in this case would be the magnitude of u plus v squared. Then our B and our C would be 300 and 400. Then negative 2 times 300 times 400. And then our included angle would be our cosine of 135. Now remember, we had to find that 135 based on the fact that we're dealing with a parallelogram. Okay, and again, this will give us the magnitude of the sum. So again, you might want to pull out a calculator. Okay. So okay, and depending on the calculator, you can do a lot of this in the calculator, or you're going to do a lot of it by hand. Make sure you're in degrees. Okay, so I get a number like that. So that's 419,705.6275. Now remember, I still have to take the square root of that. Okay? And I get that with rounding. Okay? All right, so now I have to use law of sines to find my angle of right here. Okay. Okay, and then I have to add something to it, because remember, a direction angle is measured from the positive horizontal axis. So we're going to use law of sines to find the angle in our triangle. Okay, which is right here. And then add 25 degrees, since the direction angle is always measured from the positive x-axis. Okay, here we go. Whoops. All right, so remember, okay, so we're going to do 647.85. That's our side. And that is opposite our 135. So sine of 135 is equal to the little angle that we're interested in is opposite the 300. Call that sine B. And then we're going to cross multiply. Divide. Okay, and then we're going to use the sine inverse. So we'll take sine inverse of both sides. Now again, depending on your calculator, you might be able to type this in as it's written. But it's kind of dependent on the calculator that you have. Okay, I get 19.11. Okay, so that's that little tiny angle in here, right here. Okay, now we're going to add 25 to it. So we get, oops, wrong number. And if I add 25 and I get 44.11 degrees. Okay, so now we've done the same problem in two different ways. The first way, in the last video that we did it in polar. Okay, so we converted it to polar. Okay, and we got 64785 as our magnitude. We found our direction angle as 44.11. Okay, then we did it with the law of sines and then cosines, and we got the exact same thing. So what you need to do is you need to decide how you would like to do this problem based on given information. Okay, now there's actually a third way to do it. Okay, all right, hang with me. Okay, so what we're going to do is I'm going to draw out, just as here is my, whoops. Here is my, let's see, that's u, so that's 370, right? Okay, and then next one. This is 25 and 400. Okay, so the third way is we're actually going to use component form. Whoops. There we go. So we are going to find the component form for U and V. Okay, so what we're going to do is we're going to draw a triangle. Okay, remember when we find the component form of a vector, we're finding the horizontal component and the vertical component. So your horizontal component is your A, and your vertical component is your B. A, B. So for the first one, we have sine of 70 degrees is equal to B over 300. And then cosine 70 degrees is equal to A over 300. Now this is very, very, very similar to polar form. It's just in a slightly different package. For the next one, okay, sine of 25 is A over 400, and cosine 25 B over 400. Okay, we're going to cross multiply solve. So B 300 sine of 70, A 300 cosine 70. You should hopefully be noting that this almost looks exactly like polar form, except we're not calling it polar form. We're using right triangle trigonometry. Again, this is just an alternate way to do the same problem. Okay, so let's get out our calculators. So notice these are the exact same values that I got before, but we're not using the language of polar form. Sometimes that just makes it a little bit easier for us to do. Okay, we're still doing the same thing. We're just using different language. Okay, so now what we can do is we can go Q plus B by simply adding the horizontal and then adding the vertical. And we get okay, so now we can find the magnitude by using our formula. Again, hopefully you are noticing that these are the same values we got when we ran the polar form, but we're not using, the words radius, things like that. So look at that. Same answer. You can also find the direction angle in the same manner. Okay. But again, this method uses the language of hypotenuse and opposite and adjacent instead of the polar, and you still have the same result. Skipping a few little steps here. Okay, so I hope that was helpful to you. Okay, so you have multiple different ways to do that type of problem. Okay, so you can choose your favorite one if that is an option for you.